Hello friends, in this video we're going to discuss about generating function of Legendre's polynomial. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. That's my Insta ID. You can follow me on Insta. So now let's start. So generating function of a Legendre's polynomial Pn of x is this because you see this Pn of x is the coefficient of z to the power n in the expansion. If you expand this expression, okay, in the expansion of this and in ascending powers of z, okay, where this mod of z is less than 1. Okay, so now you see this is the generating function of the Legendre's polynomial, and if you expand, then you will see that this Pn of x is a coefficient of this term, this z to the power n. Okay, so question may be asked that prove that Pn of x is a coefficient of z to the power n in the expansion of 1 minus twice xz plus z square whole to the power minus half. Okay, this kind of question may be asked. So let me show you how to prove that this Pn of x, how to prove that Pn of x is a coefficient of z to the power n in this expansion of this term. Okay, now let me show you. Let me take a new slide. Okay, now here you see, to expand this, let me express in this way. Here 1 minus, let us take z common, so minus z is taken common, then we're gonna have twice x minus z, okay, whole to the power minus half, right? So that we can apply this formula. To expand this, we're gonna use this expansion, binomial expansion. Okay, so we are to use this binomial expansion. So now you see, so this is 1. Now let us consider this part as x and consider minus half as minus n. Okay, then if you use this binomial expansion, let me make a box here. So if we use this binomial expansion, just give me a second. Okay, so here we're going to compare this one with 1 minus x whole to the power minus n. So here whole to the power, here minus n is minus half, that means n is equal to half. And here, you know, if you compare this one with this, then here we're going to consider x as z into twice x minus z. This should be considered as x. And you know, if we use this expansion, then what we're gonna have, just let me copy the first step. So then it's gonna be equal to 1 plus 1 by 2 z into twice x minus z plus minus half. Here we're gonna simply write half, negative, it will be positive. So let me directly write this one, minus half plus 1. Here you see, here half into half plus 1, we're going to consider that way. So that's going to be half into 3 by 2, okay, because half plus 1 is 3 by 2, divided by factorial 2, into instead of x square, what we have, we're going to have z square into twice x minus z whole square. That's what we're gonna have, right? So here you see, here just we have put n is equal to half to get this, and this instead of x we have put this part to get this, right? Hope you have understood this. Then here you see, then what we have done, is this minus n can be compared with minus half, so we can say n is equal to half. So this n is replaced by half, okay, and this n is also replaced by half. Then n half plus 1 is 3 by 2, so here I have got 3 by 2. Then instead of x we have written z, instead of x we have written this square of this, so that's why we have got this. Similarly the next term will be, just give me a second, let me clean this. Similarly the next term what we're gonna have is half. If you put half here, n is equal to half here, then that's gonna be 3 by 2 into, if you put half here, half plus 2 is, that's gonna be 5 by 2, right, divided by this time factorial 3, then x cube means here z cube into twice x minus z whole cube. That's what we're gonna have. Then plus dot dot. Now here you see, in this first term, here we have 1 means we can consider, here we have 1 into x to the power 0, power on the variable is 0. So in the next term we have x to the power 1, in the next term x to the power 2, where we have x to the power 2, that is third term, right, where we have x to the power 3, that is fourth term, right? And when you have taken x square here, in the third term, you see, in the third term here we have n into n plus 1. In the fourth term we have n into n plus 1 into n plus 2 in the fourth term, right? In the fifth term we're gonna have n into n plus 1 into n plus 2 into n plus 3, right? So that means if we take a fifth term, then this should be 5 minus 2. If we take fourth term, this here it should be n plus 4 minus 2, right? That means n plus 2, right? So similarly, if we take n plus 1 term, let me take, in order to get power on the power n on the variable, we need to take n plus 1 term here. Let me write it properly, just give me a second. So here you see, in this expansion, just give me a second. Okay, so if you want to write the nth term, if you want to write the term containing x to the power n, in that case, so if we have cube here, then we have here factorial 3, so here we're gonna have factorial n. So now you see this number is 1 less than this power. Similarly here also this number added to n is 1 less than this power. I'm not talking about this whole number, this one only, right? Hope you have understood this. If you follow that pattern, then you're gonna have here n into n plus 1 into n plus 2 dot dot dot. So last term should be like this, the last factor should be like this, n plus, and here you see, as I have told you, this number is 1 less than this power, so here we should have n plus n minus 1. Here you see this n minus 1 is 1 less than this power, right? And when we had power 3, this was fourth term, this was fourth term. When we had power 2, this was third term, right? So similarly this is n plus 1 term, because now power is n, right? Hope you have understood this. Now let me clean these things, just give me a second. Okay, so now okay, just okay, So now let me write this term here also for this expansion also. If we write that, then what we're gonna have, plus dot 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 plus, here we're gonna have, instead of n we're gonna have half, then half plus 1, that's gonna be 3 by 2 into 3 by 2 plus, sorry, not plus, into 5 by 2 into 5 by 2 into dot dot dot. Then we're gonna have, let me just write the denominator here, n factorial. If we want to have z to the power n into twice x z minus z whole to the power n, because we are to prove that this is Pn of x is coefficient of z to the power n, right? So that's why we have to obtain this term containing z to the power n. So now you see, as I have already told you the pattern here, that this last number is 1 less than this power in every term, each and every term. Here you see this is the power 2 and here it is n plus 1. Or you can follow this term here, this term should be n minus 1, right? N plus n minus 1, that means half plus half minus 1. Okay, we should get that way. So here we should get half plus, as we have power n here, so it's supposed to be half plus n minus 1, right? Half plus n minus 1. Now you see here, let me tell you one thing, this n should not be replaced by half, because here we are putting this n because this is n plus this is n plus 1 term, right? This is n plus 1 term. Okay, so number of term cannot be, fraction. So this n doesn't represent this power. Okay, hope you have understood this. There is a difference between this n and this n we are putting here. Okay, hope you have understood this. So here you see this n is the power here. Okay, and this n minus 1 comes because of this is n plus 1 term, right? Okay, hope you have understood this. So that's why you please don't replace this n by half. Okay, right? Hope you have understood this. So then what will be this term? Then half plus n minus 1, that's going to be, half minus 1 is minus half, so we can write here n minus half. This term can be written as n minus half, right? So now let me clean this part. Okay, just pause the video and note these things, and note this expansion also. Okay, don't ignore this expansion, note this one as well, right? So now just give me a second. Okay, now let me consider this one as equation number 1. Let me consider this is equation number 1. Okay, now you see what will be the coefficient of x to the power n in this term. Okay, now coefficient of z to the power n in this last term that I have written here. Let me copy this in this term. Okay, so what will be the coefficient? Now the coefficient will be equal to, let me show you something. If you expand this term, this binomial, then you will get the first term 2x whole to the power n. Then you gonna get terms containing z. Okay, like you see, when you expand a plus b whole square, then you get a square plus twice a b plus b square. Now here you see, if you see this interesting pattern here, the first term we have got is a square, and in the remaining terms we have b, right? We have b. Okay, similarly if you expand this, the first term you're gonna get twice x plus whole to the power n, because here power is n, and remaining terms, all the terms will contain z, at least z to the power 1, z to the power 2, at least the next term will contain at least z to the power 1, right? So we are to obtain the coefficient of z to the power n, not z to the power n plus 1 or n plus 2. So that's why, so we're gonna target the term where we're gonna contain we're gonna have only z to the power n. Now here you see, here we have z to the power n, and if you multiply z to the power n into 2x to the power n, this term will only contain, this term contain only this term will contain only z to the power n. Okay, and remaining term, in the remaining term you if you expand this twice x minus z whole square, whole to the power n, so if you expand this you're gonna get z at twice x to the power n, then in the remaining term all those terms will contain z already. So if you multiply z to the power n, you're gonna get z to the power n plus 1, z to the power n plus 2, so on. Okay, so we don't need those terms because we need the coefficient of z to the power n only, and that will be obtained in the first term only. So let me clean this slide. In the first term only, in the first term, in the sense, let me explain. In the first term of this expansion means the, let me clean these things. Okay, right. So if we expand this, we're gonna get twice x whole to the power n plus dot 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 something containing z, terms containing z, sum of the terms containing z. So if they contain already z, if you multiply z to the power n, then we're gonna get different power on z. So only term that we're gonna get z to the power n is z to the power n into twice x to the power n. So twice x to the power n, z to the power n, and we're gonna take the coefficient of this term only, term containing z to the power n. Along with this twice x to the power n, we're gonna get this part as well, right? Hope you have understood this. So the coefficient of the term containing z to the power n will be of this form, right? So we're gonna get this part, this numerical part here. We're gonna get this into, along with this we're gonna have twice x to the power n, right? Twice x whole to the power n. Just give me a second. We're gonna get this, because you see we don't need to write this z to the power n because we are taking the coefficient of z to the power n here, right? So if you take that, then what you're gonna have here, you see. Now let me copy this last term, okay, and let me go to a new slide. So here you see what was the last term. This is the last term. So now you see here what we have in the expansion 1 minus x whole to the power n. We had observed that 1 in the expansion was like this: 1 plus n into x, then we had n into n plus 1 by factorial 1 x to the power 1, that means simply x, right? So now you see here it's supposed to be x square. Here we had power 2. So if you compare, if you have half here, n is equal to half, then it's supposed to be half into 3 by 2, right? Okay, so we have got here 2 into 2 square, right? When the power on x is square, right? In the next term, similarly, n into n plus 1 into n plus 2, right? And divided by factorial 2, here we're gonna get x to the power, right? Sorry, I made a mistake. It was factorial, actually 2. Factorial 1 was there, actually that was not written because factorial 1 is simply 1. So it's supposed to be factorial 3. Okay, now here you see, if you put half here, then half into 3 by 2. If you put n equal to half, then 5 by 2. And here we're gonna have x to the power 3, right? X to the power 3. Now you see, instead of this term, if you compare, instead of x, suppose we have this, right? So here you see, here we're gonna have 2 to the power n into x to the power n. When we had power 3, here we had 2 into 2 into 2, that means 2 cube, 1 into 3 into 5 divided by 2 cube, right? Similarly, when we have power n here we're gonna get 2 into 2 into 2, that's gonna be equal to, if you multiply all these things, then you're gonna have 2 to the power n as a denominator, and this 2 to the power n and this 2 to the power n will be cancelled. Hope you have understood this. Let me explain. Here we're gonna get this part. Here we're gonna get 1 into 3 into 5 into dot 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 dot. If you take LCM here, you're gonna get twice n minus 1 and divided by 2 into 2 into dot 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 n number of 2, n number of 2's. Okay, that means you can write 2 to the power n into and divided by, we have factorial n here, then we have into 2 to the power n x to the power n, if you expand this part, right? So here you can write this one as this, in this form, this way, right? And this 2n 2 to the power n 2 to the power n gonna be cancelling at each other. So that's why we end up getting this. Let me clean this part and let me write what we have got. Then at the end, after cancellation, what we're gonna have, we're gonna have 1 into 3 into 5 into dot 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 twice n minus 1 divided by factorial n into x to the power n after cancellation of 2 to the power n. That's what we're gonna have, right? Hope you have understood this. Now similarly, what if we take a term containing n minus 1, z to the power n minus 1. So here you see, suppose we want to obtain a term where the power on z is, suppose n minus 1, power on z is n minus 1, and power on this binomial is also n minus 1, then what going to be the change in this term? So when we had power n, what we had taken here, we had taken half plus n minus 1, right? We had taken that, that's why we have got this term, right? So now, as here we have taken n minus 1 when the power is n. Now what we're gonna take, half plus, as we have power 1 less, so it should be reduced by 1 also, n minus 2. So in the previous case we had taken n minus 1, now we're gonna take n minus 2, and if you subtract half n minus 2, then what you're gonna have, that's gonna be what we're gonna have, half minus 2, right? That's gonna be minus 3 by 2, right? That's gonna be minus 3 by 2. So we're gonna end up getting n minus 3 by 2. That's what we're gonna have, right? So similarly, so if we take the coefficient of x to the power, z to the power n in this term, then what we're gonna have? Now you see here, if you expand this, the first term will be twice x whole to the power n minus 1, and next term, in the next term it will contain, the next term will contain z to the power 1. Now if you multiply this term with this, then power on z will remain z n minus 1. But here you see, in the second term, if you multiply this 2, then the power gonna be n minus 1 plus 1, that means power gonna be n. So we're gonna take the coefficient of that term, second term here. So now let me write this here properly. So but what gonna be the second term exactly of this expansion of this binomial, right? We know that kth term in binomial expansion of a plus b whole to the power n, that is given by this expansion, this formula, that tk is equal to nc k minus 1, c means combination here, a to the power n minus k minus 1, n minus k minus 1 into b to the power k minus 1, right? So if we apply that, what will be the second term of this, that is t2 of this expansion, that's going to be equal to nc. Here instead of n we have n minus 1 c, then 2 minus 1, that means n minus 1 c1, then a to the power, instead of a we have 2x whole to the power, instead of n we have n minus 1, then minus k minus 1 is in this we are going to find that second term, so 2 minus 1, so that means 1, right? Hope you have understood this. And b to the power, what is b here? Minus z to the power, here we're going to have k minus 1, that means simply 2 minus 1, that's going to be equal to 1, right? This is what we're going to have, right? So n minus 1 c1, what does it mean? That means n minus 1 factorial divided by factorial 1, then n minus 1 minus 1 factorial, that means n minus 2 factorial, n minus 2 factorial. Okay, so if you divide this n minus 1 factorial by n minus 2 factorial, then you're gonna get n minus 1 only, right? So n minus 1, then we're gonna have 2x whole to the power n minus 2, then we're gonna have z to the power minus z to the power 1. Okay, that is what we're gonna have. Now let me clean these things, all these things. Hope you have understood this. Hope you know the concept of binomial theorem, right? Now you see what we have got, n minus 1 twice x whole to the power n minus 2 into minus z whole to the power 1, right? So here if you multiply this z to the power n with this, z to the power n minus 1 with this, then what you're gonna get, if you multiply this two, then it gonna then we end up getting minus z to the power n, right? Because if you multiply this with here we had z to the power minus z to the power 1, and if you multiply with this z to the power n minus 1, then you're gonna get this, right? Hope you have understood this. So now we're gonna take the coefficient of this term, so we're gonna take this part as a coefficient along with this part, right? So that's why okay, so here we're gonna have a negative sign, so the coefficient will be of this form, negative, then into this part here you see there will be a negative sign, then we're gonna have, just let me clean this, n minus 1 into twice x whole to the power n minus 2. So as we are taking the coefficient of z to the power n only, so we have taken this negative sign and this part and this part, right? Hope you have understood this. We are taking the coefficient only, right? So that's what we're gonna have. This is the coefficient of z to the power n in this term, right? Hope you have understood this. So similarly we can obtain, here you see, from here we will get 2 to the power n minus 2. Similarly, like the previous term, here also we're gonna get this minus 1 into 2 into, sorry, not 2, 1 into 3 into 5 into dot dot dot. If you take the LCM, that's gonna be twice n minus 3 divided by 2 to the power n minus 2, and I forgot to put one more thing, this factorial n should be n minus 1. Okay, this factorial n should be n minus 1, because when we had power n, here we had a factorial n, so it's supposed to be n minus 1 because we are taking the power n minus 1 here, right? Hope you have understood this. Now you see, okay, then n minus 1, here we're gonna get n minus 1 into 2 to the power n minus 2, then x to the power n minus 2. That's what we're gonna have. Then here these two terms cancels, okay, these two terms cancels, right? So now you see, if you cancel this n minus 1 factorial divided if you cancel this by n minus 1, n minus 1 factorial means you can say n minus 1 into n minus 2 factorial. It can be written this way. If it is divided by n minus 1, then you're gonna get n minus 2 factorial, right? Hope you have understood this. So cancel this by this n minus 1. So then what we're gonna have, let me copy this, let me modify this term. Then what we're gonna have, that's then simply we're gonna have this, just first pause the video and copy, and write this up to this step, okay, up to this step, and let me show you now. Okay, then what we're gonna have now, let me clean this part. I'm writing the final result here. Then we're gonna have minus 1 into 3 into 5 into dot 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 twice n minus 3 divided by n minus 2 factorial, n minus 2 factorial, right? N minus 2 factorial, okay, n minus 2 factorial, then x to the power n minus 2. That is what we're gonna have, right? Now you see, we need to modify this term. Why we need to modify this term? We're gonna keep this part common in each and every term. So in order to obtain this part, so what we're gonna have, you see, just give me a second. So here it was 3. Now you see, if you see, difference between these terms, these consecutive terms are differ by 2, right? So that's why, in order to get this, what we're gonna have next, let me multiply here twice n minus 1, okay? So because here you see, difference between these two terms is 2, okay? Here we have minus 3, here we have minus 1, because in this pattern here you see 1 and 3, difference between these two is 2, 3 and 5 differ by 2, right? Hope you have understood that. And if you have multiplied this with the numerator, then it must be multiplied with the denominator as well, that is twice n minus 1. Here it should be multiplied, right? Hope you have understood this. Now one more thing is that, okay, let me write this part here, just give me a second. Let me write this part here. Okay, now we need to multiply more things. So we want to keep this factorial n. In that case, here you see, factorial n can be written as n into n minus 1 into n minus 2 factorial. So that's why, in order to make it factorial n, we have to multiply n into n minus 1 here, and if you multiply with the denominator, then that should be multiplied by the numerator as well, n into n minus 1 here, okay? So hope you have understood this. Then what we gonna have here, you see, and one more thing, I have missed one more thing, that is, so here you see, in this part here you see, here we had got on multiplication of these terms, if you multiply these terms, here we had got product of these two, we had got 2 to the power n when the power is n, right? Here power is n minus 1. So here if you multiply these 2's, there must be n number of 1 2's, right? There must be n number of 1 2's. So that's why we should get the product of these denominators as 2 to the power n minus 1. Now one more thing, that now we are getting this z to the power n, we are getting this from here, you see, from product of these two, we are getting the z to the power n from the second term, so that's here you see there must be, you know, as we had got 2 to the power n here we, from the second term we should get 2 to the power n minus 2, okay, not n minus 1, right? So because you see, let me tell you the let me obtain the second term of this binomial expansion. Now as I have already shown you that in this expansion a plus b whole to the power n, in this expansion the ket term tk is given by n c k minus 1 into a to the power n minus k minus 1 into b to the power k minus 1. So in this expansion of this, if we apply this formula, we are going to find the second term t2, that's going to be here, instead of n we have n minus 1, c k minus 1 is 1 here because 2 minus 1 we are taking second term, right? Then a to the power n, instead of n we have n minus 1 minus k minus 1, that means 2 minus 1, which is equal to nothing but 1, right? So b to the power k minus 1 means 2 minus 1 here, so that's why b to the power 1. So here instead of a we have twice x, so instead of a we have twice x, so we should get twice x to the power n minus 1 n minus 2, and instead of b we had minus z, right? So minus z to the power 1. So here you see, here we gonna have 2 to the power n minus 2, right? And if we get the product of these denominators is 2 to the power 2 to the power n minus 1, so as those this product will appear in the denominator. If you multiply with this 2 to the power n minus 2, then what you're gonna have? If you cancel this one by this, then you're gonna get 2 here, so we should get 2 here, okay, we're gonna have a 2 here, right? So hope you have understood this 2, okay. So I missed that one, so now hope these things are clear to you. So now let me write it properly. So here you see, okay, similarly if we follow this pattern, okay, then in the next term, that coefficient of z to the power n, in the term containing z to the power n minus 2, here also n minus 2 we can obtain. So that will be, let me write that in the next slide, okay. In the next slide we can write that coefficient of z to the power n in, so what will be the next term after this? If you want to obtain here z to the power n minus 2, then what we're gonna have? So that term gonna be here, you see, half into 5 by 2 into, sorry, it's supposed to be 3 by 2, not 5 by 2, 5 by 2 into dot. Here we had n minus half, now then we have n minus 3 by 2, then here we're gonna get n minus 5 by 2 divided by, here we had n, so here we had n minus 1, now we're gonna have n minus 2 factorial, then here z to the power n minus 1, z to the power n minus twice x minus z to the power n minus 1, so here z to the power n minus 2 into twice x minus z to the power n minus 2. So from this term we're going to find the coefficient of z to the power n. So here you see, okay, let me cut it, okay. So let me write it properly. What we're gonna have, half into 3 by 2 into dot 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 n minus 1 5 2 by n minus 2 factorial into z to the power n minus 2 into twice x minus z whole to the power n minus 2. Okay, so now similarly we can find a coefficient here also, and I'm not gonna obtain as I did here in this slide. So just we're gonna observe the pattern and we're gonna try to find a coefficient from these two coefficients. Here you see, just let me go back to the previous slide and let me copy the other two coefficients that we have got. Here you see, so here in this part here we have got this one, first one we have got this, second one this one, let me copy this one as well, we have got this, right, we have got this. And in the third term here you see, so when we had power here z to the power n and here also n, then we had got this coefficient. Then in the next term we have got this coefficient, which can be written this way also. Let me go back to the previous slide. Here now you see this part becomes factorial n, so we can simply replace it by factorial n. Let me replace it by factorial n. So here we can write, so this is nothing but divided by factorial n. So first we have got this, then we have got this. Here you see, first term was positive, this one is negative, then here it will be again positive, then here we're gonna have 1 into 3 into 5 into dot dot dot. Here you see, here also we are getting twice n minus 1, here also we are getting twice n minus 1, so here also we're gonna have twice n minus 1 divided by we simplify in such a way that we get denominator factorial n. Then here we had got n into n minus 1 divided by 2 into twice n minus 1. Here we're gonna have n into n minus 1 into n minus 2 into n minus 2 into n minus 3 divided by 2 into 4 2 into 4 2 into 4 divided by twice n minus 1 twice n minus 3. So here you see, in this coefficient, in order to obtain this coefficient we have multiplied these two terms, right? So in the next term we should multiply two more terms, that is n minus 2 and n minus 3. That is what we have done here. So why we had multiplied these two here in the numerator? Because to obtain here factorial n. So similarly, to obtain factorial n here, in this case we need to multiply two more terms. Okay, these two, right? Similarly, you see, okay, in order to obtain this twice n minus 1 at the end, okay, we need to multiply these two. Okay, and here you see, in this term, in this coefficient we can consider 2 to the power 0, and in this coefficient we had got 2, right? We had got 2 to the power 0, you can consider this way, and here we are getting 2. In the next term we are getting 2 into 4, right? So that's how it goes, right? So that means you can consider this way. So that means here we are not getting 2, means we have here 2 to the power 0, and here you see we are getting 2, that means we can consider this way, 2 to the power 0 into 2 to the power 1, and in the next term here we are getting 2 to the power 0 into 2 to the power 1 into 2 to the power 2. That's how we have got this 4, Hope you have understood this. You can observe that pattern. Hope you can observe this pattern. Okay, so these are the two coefficients we have obtained in the previous slide already. These two, just to observe the pattern I have written here. So now let me clean this. So we have got what we had needed. So now you see, here we're gonna write n, so on. So we can find more coefficients. Similarly, observe using this pattern. And one more thing, here we should have x to the power something. I missed that part. Let me go back to the previous slide also. Again, here we had x to the power n. Here we had n minus x to the power n minus 2. Here we must have x to the power n minus 4, right? That's what we're gonna have. Okay, that's how we have got. So now what we're gonna do, first let me write it properly, and so on. Now you see, from equation number 1, this equation number 1, from this equation number 1, the coefficient of z to the power in this equation number 1, if we take the coefficients of z to the power n only, then what we're gonna have, here you see the coefficient of z to the power n in equation number 1. What we're gonna have, so in each and every term we're gonna get this term, right? That is 1 into 3 into 5 into dot 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 twice n minus 1 divided by factorial n, then within bracket. So now you see, on taking this part common, from all the terms, so what we're gonna have, here we're gonna have 1, and here we're gonna have this part, and here we're gonna have this part after taking common. Not only this part, also we're gonna have x to the power this and this as well. So taking common, we're gonna have, in the first term we're gonna have x to the power 1 into x to the power minus n, x to the power n. Then in the next term, as here we had got minus, here you see, then here we're gonna have minus. So on taking this part common, here we're gonna have this part, right? Here n into n minus 1 divided by 2 into twice n minus 1. Then next part is positive, this coefficient is positive, this part is taken common, again we're gonna get this part. Here we should have written this x to the power n minus 2, and here plus n into n minus 1 into n minus 2 into n minus 3 divided by 2 into 4. Let me write it properly, 2 into 4 twice n minus 1 into twice n minus 3 into x to the power n minus 4, then next term will be negative, and dot dot dot, so on, right? So now let me go to a new slide. Let me copy this, just let me copy the last step. Okay, now here is the new slide. Okay, now you see this entire part, this term is nothing but Pn of x, Legendre polynomial. And if you don't know this, then please do watch the video that is given in the description box. Link is given in the description below. Okay, this is nothing but the Legendre polynomial Pn of x. So what is this? This is the coefficient of z to the power n. So that is what we wanted to prove, right? So therefore, you see, if you take P1 of x, then you're gonna get the coefficient of z to the power 1. Then if you take P2 of x, then you're gonna get coefficient of x square, right? Hope you have understood this. Therefore, what we can write, thus the coefficients of z to the power 2, z to the power 3, dot dot dot, etc. in equation number 1 are, in equation number 1 means this one, here you see this was equation number 1, right, are p1 of x comma p2 of x dot 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 so on, right. So therefore we can write this expansion 1 minus x 1 minus twice xz 1 minus twice xz plus z to the power 2 whole to the power minus half is equal to p0 of x. Okay, p0 of x. So we're gonna term which is which doesn't contain z, that means z to the power 0 plus z into p1 of x, because you know, in this expansion the coefficient of z to the power 1 is p1 of x, because coefficient of z to the power n is this pn of x, right. So coefficient of z to the power 1 must be p1 of x. Similarly z square, its coefficient should be p2 of x plus dot 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 so on, right. So hope you have understood. Similarly coefficient of z to the power n is pn of x, right, dot dot dot. So that is what we wanted to prove. So that's why this part, this last term, that we can write this way. Let me go to a new slide. Let me take a new slide. So here is the last part. So we can write this one using summation, that is summation from n equal to 0 to infinity, n equal to 0 to infinity, pn of x z to the power n. So this part is coefficient of z to the power n, right. So hope you have understood this. This is the proof. Okay, so see you in the next video. Bye bye. Thank you for watching.